Hello, this is the ME435 final project for Matthew Yonklis, Thomas Scooge, and Nicholas Ritchie. Over these few labs, we dove into the capabilities of the Dobots and the software Dobot Magician. In the first lab, we covered the basics of how to turn on and connect to the robot. We then went into the kinematics of the Dobot and the different settings that affected this movement, such as jump and joint movement. This led us to changing the end effectors, which were gripper and suction cup, and the corresponding program. Furthermore, we were able to connect to a conveyor belt and use the I/O communication with the infrared red switch to perform tasks. The first task, as you can see in the video, was to make the conveyor belt stop when the sensor detects the block and then remove the block, which we use the suction cup to do. We were also tasked to do a 2D code recognition of a QR code, which utilized the camera. Our final task was then to create a continuous code that worked without human intervention. We used the infrared sensor to stop the conveyor belt and allow for the Dobot to pick up the block. The Dobot then moved the block further back on the conveyor and the cycle continued. As you can see in this video, we were able to properly perform the continuous task using both the suction cup, conveyor belt, and infrared sensor.
In Lab 2, we utilized the Dobot's vision system. Our team learned how to capture and save images. We took a grayscale image of a Nittany Lion logo and used it as a template. Then we used the match command to detect the logo, and we were able to only search for them in a specific region. We also learned how to use point-to-point measurements between objects. This is shown in this video. The next part of the lab was important for our final project. We learned how to create a calibration file for the vision-guided robotics. We also learned how the camera is able to detect different colored blobs. Our team used color extraction, image morph, and blob functions. This video shows the robot differentiating blue blocks from the rest.
Our final preliminary lab was our Lab 3, which started with the use of the sliding rail. After getting our robot to move on the sliding rail, we teamed up with another group in order to complete a Dobot handshake. This started with us creating our Arduino circuit with a sending and receiving side, which were then connected to the respective Dobots. Each team also created their respective flowcharts for their task. This allowed for us to move our Dobot on the sliding rail, stop, light up the LED on the Arduino circuit, and then the other Dobot move on the sliding rail. We also used the Dobot to Dobot communication for our next task, which can be seen in this video, where we pass a block to the other Dobot and then they move it to the final location. For our final task in this lab, we did a vision-guided rectangle template match. We started with creating a calibration file as done in Lab 2, and then created a feature match to find rectangles. Then using the calibration file, we converted the image coordinates to physical coordinates, which allowed for us to find and pick up the rectangle. We then used the fast match function to locate rectangle model slots. Then using a script, we calculated the rotation angle in order to align the rectangle with the empty slot, and finally place the rectangle in that slot.
Our final project idea was to have one Dobot play tic-tac-toe against a person. A person places a blue block, and the robot responds with another placement of a red block. At the end of the game, the first robot recognizes that there's nothing left to fast match and sends a signal to the other. The other robot clears the pieces from the board and prepares it for the next game.
The code we used to achieve this was mostly from Dobot Labs 2 and Dobot Lab 3. The tools that we used to achieve this was the color extraction, image morph, and blob, using also the fast match from Dobot Lab 3 to find the exact place on the board to place the pieces. As you can see, the color extraction, image morph, and blob are used to identify a block and place it on the board in an acceptable position or open position left on the board. Us, the players, then place a block to oppose the robot as if we were another player, and then the Dobot continues this by running the code again. This happens 5 times for the first robot to simulate, 4 times for the first robot to simulate a game of tic-tac-toe. Then the code used by the second robot is very similar to the first, in that it identifies the red blocks using color extraction, image morph, and blob, as well as the calibration tracking and the suction and move blocks to identify the red blocks and clear the board of the red blocks as if it was the same as the first robot completing the game of tic-tac-toe. As you're about to see, you will watch, now that the first robot is done, the second robot starts up and starts clearing the board of the red blocks only, making sure not to clear the board of blue blocks, as those are the player's responsibilities to remove. And that is how we got our robots to talk to each other in completing a game of tic-tac-toe.
Thank you for watching.